Namaskar, I'm Kannan from JK Associates. I have a industry experience of over around 40 years in various tire companies in India as well as abroad. I have also had the privilege of working in the technology, quality, production, and some part in sales and marketing as well. And my diverse experience in the various aspects of tire industry clubbed with the technological advantage of having worked in technical department made me a very strong process person clubbed with the quality orientation and quality focus. Today I'll be touching upon a subject which is very important in tire industry, which is calendaring operation of a 4-roll calendar. As we all know, 4-roll calendar deals with calendaring of nylon or steel cord fabric, which is the most highly priced raw material within the, among the raw material that is used in making of a tire. So any kind of a control which is not good or adequately placed will lead to a huge scrap generation, and it will be directly hitting the bottom line because it will increase operation cost. It will also create a low morale for working, and it also over a period of time deteriorates the machine. So it has a very impacting situation on a tire company. So it is very, very important that we understand the critical aspects as well as the preventive cares and concerns that we have to look at while maintaining a 4-roll calendar, both as a machinery and as a process. I am retired from a tire company and I'm having my own consultancy, which is called the JK Associates, mostly on the process training of the tire manufacturing as well as on the quality aspects end to end on the quality management systems as well as the deployment of total quality management practices. So it gives me great pleasure to be here with you again on this tire business techno talk platform, sharing my knowledge as well as giving some tips about the process and facilitating or enabling the current generation of users in the tire industry, how we can overcome the critical nuances as well as the critical process control in 4-roll calendaring in a tire industry. Thank you. Namaskar. Welcome to Rubber Industry Tech Talk. I'm RS Kannan of JK Associates. Today I'll be covering on 4-roll calendaring process in a tire industry about setup, operation and control. Before we get into any kind of a learning mode, there is a shlok which tells the purpose of learning and how it culminates into a total sheer joy and spreading joy around. Vidyam dadati vinayam, vinayat yati patratam, patratva dhanamapnoti, dhanat dharmam tata sukham, which means true knowledge brings humility. From humility comes worthiness. From worthiness, one gets wealth. From wealth, one does good deeds, and from that comes joy. So the entire living in this planet universe is basically to spread joy all around within the self as well as to people around. So we now get into the process of understanding what a 4-roll calendar is. So basically, what is a 4-roll calendar? It is an equipment that is used in tire industries, typically for creating a uniform extruded sheet. So the entire operation, which is summed up as a SIPOC, is supplier input, process output, and customer. So the supplier is, in this case, we get a diff fabric coming from the raw material stores and mixed compound, final compound coming from the Banbury, and these becomes the two major inputs. Process is coating the dip fabric on either side using the rubber compound to get a uniform thickness of the rubber and meet all the technical properties as specified. Output will be called as a calendared fabric roll of a desired width, length, and a specified gauge with balance of coat on either side equal. And the customer, this 4-roll calendar output of calendared fabric roll goes into bias cutting for the next stage of operation. Now, what is calendering? Like I said, calendar is an equipment which is used in tire industry for coating the dip fabric with both sides by rubber. Calendar is also used for creating a uniform rubber sheet of even thickness. Calendars are also available as a profile calendar where we can keep some kind of a die and take a different extruded dimensions of our requirement. So it's a process by which compound rubber is used to create a desired profile either on a plain rubber sheet or topping of dip fabric by coating on either sides, or even the steel wire, which will form an integral part of reinforcement in a tire. Basically, we have different types of calendering machine. There is a 2-roll and a 3-roll, which is primarily used for a cushioning purpose to create a rubber sheet of a thinner gauges. And there is a fabric calendar, which is basically used for coating the rubber, nylon, steel, cord, whatever it is, on either side with rubber. You can even have a 3-roll calendar to be used for coating the rubber of nylon fabric, but only thing, it will be done in 2 passes. So now there are modern calendars available, and calendars are also are different types. One is inverted L type, one is L type, one is S type, and one is Z type. These L, S, Z, these all indicates the positioning of the main stack of rollers and how it appears. So we will see it in the pictorial form in the slides to come. And there is a steel calendar. There are 2 processes. One is the creel room loading, where the spools are loaded in a creel and then the wires are drawn and then taken through a kind of a reed and pass through the extruder, calendering machine to get a coating. Other one is a square oven, completely woven fabric of steel is available, and then directly you take it like any other normal nylon or rayon fabric and pass through calendar and get it coated. So types of calendering: fabric calendering. A 4-roll calendar is used for calendering dip fabric. The fabric calendars produce an upper and lower rubber sheet with a layer of fabric in between, and the impregnation of the rubber into the interstices of the fabric forms a good homogeneous, well blended calendering. And this coating has to be even on either side of the fabric for the simple reason this gives a insulation to the particular reinforcement, which is eventually going into the tire for strengthening the tire ply rating which is required. Squeegee and inner liner calendering, which is done in a 3-roll or 2-roll calendar. Basically, it is a sheer rubber of uniform thickness all around on a specified width, and it can be varying from around 0.20 mm or 0.25 mm up to some 3 mm of thickness. And this is done using a steam as a heating medium to create a uniform profile. There is a steel calendering which talks about a 4-roll calendar used for calendering oven steel fabric. It like pre-oven steel fabric which comes, it can be passed through the calendar like a rayon or nylon and coated on either side. And in other case where there is a creel room loading facility is available, then the steel wires, designated steel wires are taken in spools loaded into the creel, and the wires are drawn with a uniform tension and then pass through the calendering, and it is coated on either side of the fabric, steel fabric with the rubber to get a uniform gauge. So this we have seen. So this is the shape how it looks. If you look at this shape of this arrow which is shown here, so this is in the form of a Z. So this is called as Z type calendaring. And here if you see, this is the inverted L, where the normally when you write L, like we write like this, so this is on this type. So you have one roll here, one roll here, and then another two rolls following by the sides. And then there is a S roll, which is the shape of S here. So that is, it's called as S type calendaring. But basically the purpose of all remain the same. So what is a calendaring unit? A rubber calendar in basic form consists of two or more hardened, accurately machined metal rolls rotating in bearing journal boxes, which are set in rugged iron frames. These are all completely high tensile steel. What is important here is the preparation of the roll itself is very highly super technical, and that plays a very vital role in the longevity of the roll in the running. At least one roll is equipped with screw downs to control the thickness. In fact, all the four rolls in the modern calendars are equipped with the screw down motors, so that individually each roll can be lifted up and down, and that facilitates a very uniform and exact accurate gauge control. Adjacent pairs of rolls rotating in opposite direction form a nip, where a material being processed is squeezed into sheets or is laminated to form a desired product. A nip is nothing but a confluence of two rolls when it is rotating in opposite directions. Then the gap in between the two allows to set the desired gauges that we want by passing compound through that. The drives for the rolls include constant or variable speed motor and reduction gears to achieve roll surface speeds required by the processing requirements of the material. So like the speed can be adjusted for individual rolls. The speed can be adjusted in such a way to get a uniform calendared output in the fabric to get a proper gauge and the coating of the rubber. So classification methods, again we said 3 roll generally is used for squeegee and 4 roll is for fabric calendaring. So when we see here, this is what is a setup on a profile, a cross profile. You have this roll setup in a Z form, and this is called as roll number 1, and this is called as roll number 2, this is roll number 3, and this is roll number 4. And generally roll number 3 is called as a master drive, which controls the entire speed and operation of the calendar. So when roll number 3 controls the entire speed, all other rolls can be made to work with reference to the roll number 3. And generally roll number 2 and 3 gap is called as the fabric nip, in which the fabric passes through between roll number 2 and 3. So the speed of roll number 2 and roll number 3 always remains the same. This is to facilitate that when the fabric is moving, it is not having any undue problem of rubber getting accumulated behind and causing a kind of a calendaring issues. The roll number 1 and 2 form one of the compound nib. The compound is fed in between roll number 1 and 2, and this will, since the rolls are rotating in opposite direction, the rubber which is fed here will form a coating of rubber sheet behind the roll here in this form. And roll number 3 and 4 is again a compound nib, where the compound is loaded in between roll number 3 and 4. And here again the rubber is a thin layer of rubber is formed behind on this roll. And since we have the rubber coating behind on roll number 2 and roll number 3, and the fabric is passing through roll number 2 and 3, this rubber gets over onto the fabric and gets impregnated into the fabric. And finally when the output fabric comes, it comes as a calendared fabric. So this is how the process works in a simple way. Okay, now there are different functionalities of all the four rolls. So a modern high-tech calendar has something called as roll camber or roll crowning. What is a roll camber or what is a roll crowning? There is a uniform, if you look at roll camber is a process where on the roll there is a profiling given at the center tapering towards the end. So this facilitates as the roll wears out in the long run, then the gauges can be still made good, and every time we cannot take the roll out for recambering or for grinding. So the in order to prolong the life of the calendar roll, it is generally advisable to start the new calendar when we are buying to have the crowning at around 6 thou, which is around 0.006 inches across the diameter. Then this roll cambering is a facilitation available on roll number 1 and roll number 4. Basically, roll number 2 and 3 are plain rolls because fabric is passing in between the two rolls. So we don't want any kind of a profiling there. It has to be smooth and plain roll. And in order to enable the wear out that is taking place on roll number 1 and 4 over a period of time, to compensate the wear out, we have something called as a facilitation of roll bending, which is given to roll number 2 and 3. So as the camber or crowning keeps reducing over a period of usage, in order to compensate the wear out, you can increase the bending proportionately on roll number 2 and 3 to ensure that overall thickness of the calendared item, whether it is a rubber or whether it is a fabric, it remains the same throughout. So roll cross axis is another facilitation which actually on the same axis the rolls are shifted slightly. This is to ensure the flow of rubber going into the sides to compensate the edge gauges loss. So this is again available on roll number 1 and roll number 4. And there is something called as friction ratio, which is on roll number 2 and 3. They run at the same speed. So the friction ratio between them is 0. Whereas roll number 1 and 4 can be made to run at a differential speed, maybe up to plus minus 25% of roll number 2 and 3. This is to facilitate the fabric quality of the fabric processing. This again, these are all the provisions given in the setup of the calendar. However, the controls whatever we need to have is totally dependent on independent operation that is seen in different usages. And the line speed is taken as the speed of roll number 3 because that is a master roll which is controlling the entire operation. Then there is a feeding of stock that should come to the calendar. It should be in a continuous flow and it should be in a regulated and controlled flow. So there are many types of feeding which is available. One is you can have one more calendar feeding uniform strip into this nip of these calendars. You have mills which are used for cracking the compound, warming the compound, and then finally ensuring that desired quality of the compound is fed into the calendar at a desired width and the gauge. Then there is a third one which is called as there is a extruder available. So from the extruder, you chop this entire rubber compound and convert it into pigs. Pigs is the small rubber pieces, and then it flows onto a mill, and then from there you actually feed it to the furrow calendar. So this is called the pork chop extruder. So feeding can be done through mills, which are 84-inch mills or 60-inch mills, depending upon the capacity and the speed at which the calendar runs, so that the feeding capacity should be adequately there. It can also be fed through pork chop extruder, which means the sheet is rubber sheet is directly loaded into the extruder, and then it is cut into small pigs, and then the pigs are actually loaded into the mill. From there, it is sheeted out and sent. and there can be extruder also, which can be feeding the sheet also. The warm stock is then fed into the feed mill. So basically, the operation of mill operation starts with a cracker. There is a set of two cracker mills. A cracker mill is a one where front roll is smooth roll and the back roll is a corrugated roll. The purpose is to crack and break the compound so that the nerve of the compound is broken in the first mill, and it will form into rough pieces falling down and then made into a smooth band. And once the band is done, then it is moved into a warm-up mill. Warm-up mill, as the name suggests, it is for warming the compound, and it is to ensure that the compound is maintained at a certain temperature and with a certain level of viscosity for facilitating the processing of the compound in the calendar. And this is usually at around 90 to 95, and these are all indicative temperatures. It all depends upon the individual specific operation that is available. Then from the warm-up mill, it goes to the feed mill, which is again further consolidating and ensuring the breakdown of nerve of the compound and maintaining a uniform viscosity that is required for feeding into the calendar. From the feed mill, the strip width is specified and the strip gauge is specified, so that based on the requirement of maintaining a uniform bank at the nip, then the stock is regulated continuously without interruption. This can also be done through extruder, and there is a TCU to control the temperatures of input water temperature in the four rolls. And like any other temperature control unit, this temperature control unit is to ensure whatever is the input temperature of the water coming in, that is heated to a certain level and controlled at a certain temperature as per the specification, and it is sent into the calendar rolls. This temperature, when it goes into the calendar rolls and when it returns back, there would be some loss of temperature. So in order to regain the temperature, again the water is getting heated further to come to the original level. So this TCU has a heating element there in the form of a steam or electric, whichever be the case. And when the temperature goes little high, then the temperature has to be brought under control. So then there is a cold water circulation which is going to offset and bring the temperature. So it's a continuous process. There is a valve available, and it will be controlling the process continuously to ensure that the temperature which is going out of the TCU into the calendar is maintained at a given specified temperature. And the mill rolls also have a friction ratio. This is in order to ensure that the two rolls, when they are rotating, one rotating faster and the other one rotating slow, ensures the compound is actually made to go through a good grind in the nip, and it is getting a very good breakdown of or breaking down the nerve of the compound. Diff fabric is loaded at the let-off side on a dual let-off to facilitate continuous operation. The purpose of dual let-off is to ensure that operation runs continuously without stoppage. Why we should not have stoppage? Because whenever the calendar stops, even for a small time, like 1 minute also, there will be a lot of scrap which is getting generated because of the operational concerns. So it may any stoppage also will induce a variation in the gauge, the pressure variation at the nip. So it is ideal and very, very essential to ensure that calendar does not stop and it runs continuously. And in order to facilitate this, we have a dual let-off, so that one let-off, when it is getting over, there is a compensator which takes care of the loading of fabric into the calendar by the time the second let-off fabric is made available to feed to the calendar. The pneumatically operated braking system is set to get uniform tension. Everywhere the tension is very, very important. The entire tire industry operates on a 3T formula: the time, tension, and temperature. So everywhere tension is very important, and when it is a nylon or rayon fabric or polyester fabric, it is all the more important, because any extra tension which gets into a stretch mode will completely change the properties of the fabric. So it is very, very essential to ensure the uniform tension as specified in the specification. There is a splicing station to join two different rolls. The joint can be done on a electrical heating or on steam heating, whichever be the way. Basically the temperature has to be generated in the splicing platen, and the fabric is kept, and then there is a intermediary one rubber piece is kept, which is a fast curing compound, practically to facilitate a quicker time curing between the two fabric and the stock compound inside. This ensures that the joint is held together completely without any problem. And what is more important is this joint timing has to be very critically monitored and reduced to as low as possible without compromising on the quality of the joint, so that this will facilitate the easy feeding of fabric into the calendar uninterrupted. So this becomes a very major concern in the processing time. If the temperature is not okay, or if the rubber that we are using, the fast curing rubber that we are using, if it is overaged or something like that, so then this will make a weaker joint, and any weaker joint will subsequently induce more of a problem in the process, because the joints may snap and cause a bigger damage in the form of a scrap. Then the dip fabric from the let-off stand passes through pre-tensioned unit and enters the let-off fabric accumulator via center gate system. So a good calendar has lot of guiding systems. One is the center gate system at the entry of the accumulator and at the exit of the accumulator, both at the let-off as well as at the wind-up. And there are a lot of width regulating controls in the form of in the form of spreader rollers. It can be a J-web spread roller, or it can be a duo canter, or it can be a track canter. So all these facilitate the smooth passing, as well as ensuring that the width is maintained, and the fabric tension is also maintained. There are low tension and high tension spreaders controlled by PLCs to regulate the control the width as per specification. This is what I explained. So basically the width has to be restored. Any fabric, when it is running on a long train length, it has a tendency to narrow down and lose the width. So the width has to be regained and recomposed, so that the desired width goes without impacting the positioning of the cords within an inch, which is called as ends per inch, and ensure that there is no crowding of the cords, or for that matter there is no spreading of the cords. There is a set of hot cans provided to remove the potential moisture before dip fabric enters the nib. Basically the fabric, which is whether it is nylon or rayon, they are all hydroscopic and they have a tendency to absorb moisture. And whenever the fabric is going in an open um, condition, then the ambience, whatever is the humidity in the ambience, this is quite good enough to impact the fabric. So it is essential that when the fabric is getting into the nib, before that all the present moistures in the fabric are removed to the greater extent. So in order to facilitate that, we pass it through a set of hot cans. The hot cans are normally controlled either through steam or electrically heated around 100 to 105 degree temperature. This should not, because nylon has a tendency to shrink when it is exposed to heat. So it should not be at a very high temperature where the fabric has a tendency to shrink and cause a problem in the post calendering properties, as well as on the scrap. At the same time, it should be facilitating to remove the moisture. So that is a control that we have on the hot cans. Stock is fed into the calendar between 1 and 2 rolls. That is, there are 2 compound nibs. One compound nib is between roll number 1 and roll number 2, and the second compound nib is between roll number 3 and roll number 4. So when you feed the compound, you feed it in between roll number 1 and 2 and roll number 3 and 4. And this, when it is fed under a well directed uniform supply of compound coming with a proper gauge and strip width, it ensures a uniform rolling bank in the nib. And anytime the bank is controlled, then the gauge profiling will be very perfect and uniform. When the bank is more, then the tendency of the compound to push through and create a kind of an uneven gauge is highly possible. So we have to ensure that the bank is controlled well, and for that the stock supply has to be continuously coming without interruption. The rubber will be coated on the fabric which is passing between roll number 2 and 3. Roll number 2 and 3 nib is called as a fabric nib, and roll number 2 and roll number 3 are running at the same speed. So it will allow the fabric to pass comfortably without any friction. And the rubber coating which is formed on roll number 2, behind roll number 2 and behind roll number 3, they actually get impregnated with the fabric and then come out as a calendered fabric. After the cooling of the calendered fabric by passing over cooling drums, it passes through an accumulator. Like we have a hot cans for ensuring removal of any kind of a potential moisture. We also have some set of cooling drums. This as the calendar comes out of the nib, it will be somewhere around 95 to 100 degree temperature. So when the fabric is coming out, it has to be brought down to the room temperature by the time it gets into the liner and wound up. So how to bring it to the room temperature? It is by, as it is when it is passing in the ambience, there will be influence of the ambience which will be reducing the temperature. However, for a controlled temperature to be uniformly available, we pass the calendered fabric through a set of cooling drums, and the cooling drum is maintained at a water temperature of around 25 degrees, and so that it doesn't sweat on the roll. Once the temperature is lesser than 25, then it has a tendency to be a chill water, and then the chill water have a tendency to cause sweating on the drums, the cooling drums, and the sweating of the drums, when it happens, the water may contaminate the fabric and again moisture will pick up. So we don't want a situation where you use a chill water. We need only a treated water which is coming from the cooling tower, so that the temperature is maintained around 25 and the pressure is, water pressure is also adequately maintained around 20-25 psi to ensure that the water is circulated in the drum and it extracts the heat of the fabric when it is passing through them. The coated fabric is then passed to the post tension rollers, and there is in some cases you have a pick breaker, in some cases you don't have a pick breaker. It depends, and there are two facilitations given. One is called as a pick breaker, one is called a piercing roll. The piercing roll purpose is just to pierce the roll, pierce the fabric across the width in order to facilitate the removal of entrapped air in the tire building process. And the pick breaker, the main usage of pick breaker is to cut the weft part or weaken the weft part when it is in the post calendering, so that it does not allow the fabric to get stiff, and neither it allows the fabric to be tighter when it is applied onto the drum in the subsequent processes. Post this, there is a dual wind up. Like we had a dual let off, we have a dual wind up to facilitate continuous operation without stoppage. And the final calendered roll is weighed and then taken to store on racks rested on the shelves. Basically, there are a lot of methods available for this storage of calendered rolls. You have a storage rack wherein, as the rolls are loaded, it will automatically facilitate the first in first out process also. If that kind of a facilitation is not available owing to the space constraint, then you can make two railings of a steel platform and ensure that the fabric is rested on the shell, so that the fabric is not kept on the floor and the fabric is not subjected to touch the ground, that liner is not subjected to touch the ground. And basically, when you have the first system where the roll storage is done with a first in first out naturally facilitated, then your first in first out is going to happen smoothly. If you are going to keep it on any kind of a rail platform, then the first in first out has to be managed properly, either using a Kanban process or any man controlled process. Then there is a sample taken from this calendered roll, from every one calendered roll, and then the sample is sent to the laboratory for various tests like etch adhesion and tensile properties, as well as a bigger strip of fabric is sent for doing the peel adhesion, which says how good and how best the compression has happened between the fabric when it is getting coated on either side. And then the laboratory gives approval, and based on the approval, the fabric is sent to the subsequent downward processing. The operator has to ensure conformity to the calendar fabric gauge, width, and skim balance. So what is width is very clear. The width maintenance has to be absolutely on the dot. Higher the width may be beneficial to the company, but then it is not good to the tire. But lower the width is absolutely detrimental, because when the width goes lower than the specification, there is a tendency of the cord to get crowded, either mostly at the edges, selvages, or even through the body. So that increases the number of edge in an inch, which we call as the ends per inches, EPI. When the EPA goes up, then the insulation around the cord actually comes down. It becomes very less. And when the insulation around the cord goes less, it has a high tendency in the field to fail faster, because when the tire is rotating, there is a tremendous amount of heat is generated, and this heat will eat away the insulation, which is very thin, and enable and finally lead to cord chafing, cord rubbing against each other, and then causing a failure. So insulation is very, very important. So from that perspective, having a little higher width is much better and safer than having a lower width. So, but ideally it is best to keep the control of the width on the specified level within the tolerances, so that we ensure the EPI also is in place and the cord insulation is also in proper order. Any non-conforming material should be handled as per the NC procedure. So there is a typically defined non-conforming handling procedures specified in every company, how to handle that. So any kind of a non-conformance seen in the process of calendaring has to be critically followed, by ensuring that the roll is held and then handled as per the procedure. The calendar speed, it varies. There are calendars running at around 19-20 meters per minute to 70-80-90 meters per minute also. It all depends upon what kind of a facilitation is provided in the equipment. But generally you see that 40 to 60 meters per minute calendars are generally in vogue. But there are high speed calendars also going at 90 meters per minute. There are two screw-down motors for the operator and non-operator side, used to adjust the compound nip to facilitate. Basically, when we say screw-down motor, we said that all the four rolls are independently possible to be moved up and down because of the screw-down facility. And the screw-down facility ensures there is something called the water side and there is something called the drive side. So you can adjust the nip of the calendar by taking this roll up and down using the screw-down motor, to ensure the uniform thickness or gauge across the width of the calendar. Now, when you do this, it has to be very clearly ensured the movement, whatever we are doing, it can be happening only at the sides. The gauges at the center is a resultant factor. That is why we insist on having the camber on the roll number 1 and 4. So the camber ensures the uniform thickness across the width, and this screw down motor ensures the up and down movement of the calendar rolls independently, and meet the required opening that is required at the nip. And there are two screw down motors for operator and operator used to adjust the nip to facilitate roll number 1, 2, and 4. There is a splice relief system available near the main stack to identify the splice and allow the splice to pass through the nip. Whenever the joint is done at the let off, the thickness of the joint is it has to be obviously more than twice the thickness of the fabric, because there is a fabric, there is a rubber, and there is again fabric at the time of joint. So this thickness will be more than 2 times the fabric thickness. So when it is coming into the nip is actually set for a certain gap opening, and now when this higher thickness is going to enter the nip, there is a possibility that the joint may snap. So in order to avoid snapping and also ensure the process runs continuously, there is something called as a splice relief. So there is a sensor which finds out as the splice is coming closer to the calendar nib. It senses the distance is specified, so that it senses the nib coming and adjusts the opening to allow this joint to pass through without any problem, and then it closes again. So this is called as a splice relief system. and this is not present in all the calendars. Only sophisticated modern day calendars for roll are provided with the system. Now this is a cross-sectional view of a 4-roll calendar. So we start with what is called as a let-off. You have a dual let-off here, and then there is a splicing press. There is a platen available, and this is electrical or steam controlled one. And after that, there is a complete accumulator. In this place, you also have a tension rollers, pre-tension roller, and then there is an accumulator which is taking the fabric to go up and down in a sequence, so that this full position is an open position and this is a closed position. So whenever the fabric has to be joined at the let off, first the accumulator is taken to the open position, so that when the accumulator is in full open position and when the let off is stopped, then this accumulator starts feeding the calendar roll and it starts coming down slowly. So there is a safety limit at which it is locked. So beyond that position, when it goes, then the calendar stops. So you have to ensure that the time that it takes from accumulator coming from the top position to the rest position, within that time the entire operation of splicing has to be completed and it has to be controlled. So this is a very key element, and that is why it is very important that we ensure the splicing time is kept at the most minimum, at the same time ensuring a proper good splice. And then you have a tension unit, you have the spreader units, and then when it is coming, then you have a hot set of hot cans here. So you have the heating cams actually ensures the removal of moisture from here. Then it goes to the stack of calendar. Post calendering, it is coming to a set of cooling drums. Then the cooling drums ensures that excess heat is removed, and then it is taken again to the accumulator, so that there are two wind-ups given and there is a pull roll here, and the tensions are all across specified at the independent locations and the tensions are maintained. So when the roll has to be changed in the wind-up from A to B wind-up, then this accumulator feeds the wind-up station. So this is in short about a cross-sectional view of a schematic diagram of a 4-roll calendar. So the same thing is given in a process flow method. There is a dual let-off stand. From there it goes to the splicing. From there it goes to let-off pull roll. Then it goes to the let-off center guide system. Then accumulator. The center guide system is always present before the entry to accumulator and exit of the accumulator. So post let-off there is a center guide. There is a pre let-off, there is a center guide. This ensures that the fabric is centered to the machine, the main core of the machine. Then this is E plus L center guide, which is actually center guide is generally maintained by E plus L. And there is a low tension spreader which ensures that the width is regained and retained at different intervals as the line is passing through, so that the fabric doesn't get crowded. Then it goes to a set of hot can so that it removes all the moisture from the fabric, and it goes to the pull roll unit. Then it goes to pre-tension stand and high tension spreader. After that it holds the fabric so that there is no possibility of a slackness of fabric going. There is a 3-finger spreader which is actually doing the control of the edge spreading of the fabric, so that EPA at the edges are kept properly. Then it goes into the 4-roll calendar between roll number 2 and 3. Then there's a post tension stand, then pull roll stand, then there's a cooling drum, then pre-wind up center guide, then accumulator, post wind center guide, then poker and a pricker. This is what we call as pick breaker or poking unit. And from there it goes to wind up pull roll unit. Then there is a load cell which determines, and then it is taken on a dual wind up. Now after the wind up is done, the fabric is lifted using a hoist and carried away to the storage rack position. In this process, you can mount a weighing system onto the hoist itself, whereby you can weigh each and every roll. The purpose of weighing each and every roll is there is a kind of a pre-weighed empty liner roll weight available for every liner. So now I am taking the calendar fabric of a desired some specified length and with a specified gauge going into the liner. So I have a weight per square meter of the fabric, multiplied by the width of the fabric. It gives me the weight per the linear length of the fabric for 1 meter. I have got so many meters rolled into this liner. So multiply that. So theoretically, you can compare what is the difference between the actual calendar roll weight and the theoretical roll. If the weights of both are almost matching, that means the calendering has gone good. Suppose if the weight has gone lesser than the theoretical weight, that means the gauges are lower. So then it gives an indication to stop and check before it is sent to the onward processing and cause any kind of a further damage to the tire. Okay, now there are typically when you operate a calendar, fabric is a very expensive material, one of the highest raw material prices in making of a tire. So any scrap generated out of this is going to cause a very big problem to the operation and to the cost of the tire also, because the manufacturing cost will go up with the scraps keep moving up. So you have to maintain a balance between the cost, the scrap usages, or cost of poor quality. We want to maintain it at a certain level. Then we have to ensure that the fabric is not getting into a scrap mode. So what are all the reasons why a fabric will go to the scrap? One is if my gauge is not okay. If the gauge is more or less beyond the acceptance level, then the fabric will have to be scrapped. Then there are physical damages or physical deformities, like you have various defects like bare, crash, wrinkle, split, crash, rubber peeling. So all these kind of deformities, when it happens in a calendered fabric, then the fabric becomes unusable and it has to be graded as a scrap. So what are the precautions that we can take? What are all the controls we can take in order to prevent all these things happening? So how to solve the issues with calendar gauge control? The first one is a gauge, which is very important. So here are the 5 tips on how you could solve the issues of gauge control. Keep the rubber calendar running. The calendar should not stop under any circumstance. Whenever, as I said, whenever the calendar stops, then the nip pressure varies, it goes down. And not only that, the impression of the nip comes on the calendar. And because of the nip pressure going down, and when the calendar stops, the temperature also has a tendency to go down. So you will have a gauge variation happening, and you will have a bare coating of the nip impression coming on the fabric. So you should not have that and lead to a gauge variation. Increase the temperature by 5 degrees Celsius when you stop the rolls. So when you are having a unexpected roll stoppage, and it is becoming inevitable for you to stop and then correct the process, in such a time you need to actually maintain the roll temperatures by suitably regulating the TCU temperature. So you can work up to increasing the temperature by 5 degrees Celsius to all the rolls for certain time till the temperature balances and the coating of the rubber becomes uniform. Then you can reduce it to a original specified level. Limit the temperature rate of change at all times to maximum of 3 degrees per minute. So any rate of increase happening in the temperature in the TCU, it should not be more than 3 degrees per minute, because suddenly increasing the temperature, suddenly decreasing the temperature, both can lead to a fluctuation and cause a gauge variation. Minimize speed changes. In fact, the speed changes should not happen at all. If a calendar is set once and then it is supposed to operate at some x meters per minute, it has to run continuously at x meters per minute. That is why we say the reason why the calendar speed will have to change is either the let off is not doing the operation of splicing on time, or wind up is not doing the changeover operation in time, or the supply of rubber coming into the calendar nip is not continuously happening. So as these are the 3 major deterrents, we have to extremely focus on these 3 facilitations to ensure that rubber component is always fed continuously to the calendar nip, the top nip and the bottom nip. and ensure that the let off operation as far as the joint is concerned, it is done in such a way that you don't have any kind of a slip or delay, thereby leading to stoppages of the roll. So this is very, very important. And mill management is very, very important. So if it is a mill management, it is mill management. If it is a extruder management, if it is like a pork chop extruder, then it has to be ensured that the material is compound is fed into the pork chop, and the cut pieces are coming into the mill in a continuous form. So if these 5 things are taken care, so then we are fairly assured of a uniform gauge running at all times. This is subject to the condition. There is a variation coming because of the profiling of the road, like camber is worn out and things like that. Assuming the camber, everything is set for a given process, when we keep these 5 things, continuous running of the calendar, no speed reduction, and continuous feed of rubber to the top nip and the bottom nip, and increase in case of a temperature has to be built up in order to provide a uniform gauge, then don't change the temperature beyond 3 degrees per minute. So if we maintain these 5 cardinal rules, then absolutely the calendaring will be perfect. Limit the temperature rate of change. Why we say this? Because faster rates can damage or warp the rolls. Faster rates or change do not allow for equalization of mechanical expansion throughout the rolls, bearings, and calendar frames. Differential expansion can stress various components of your calendar. In extreme cases, they can actually crack. Once the roll gets cracked, then it becomes a very serious major trouble, and it has to be changed. So it becomes a two-pronged problem. One is the loss of time will be so high, change of rolls and all, and availability of rolls has to be there immediately in hand. So it is always preferable, rather than crying after the crack has happened, prevent all those things in a preventive control. Again, it is important to keep the calendar running during warm up and during cool down. So any temperature, as we start the calendar, from the room temperature, and we want to take the calendar roll temperature to say 80 degrees centigrade. So from a room temperature of 30 or 35 to 80, when you take it up, you can't straight away take the temperature to 80. It has to be slowly built up. So my room temperature is 30 or 35. I first take it to 40. Then after some time, I take it to 40, 50. After that, I take 60. So as the temperature is elevated from a room temperature to the desired temperature in a gradual way, then the roll also behaves better. If there is a sudden thing, then there is a thermal shock which can come. Similarly, when you are bringing it down, when the calendar is shut down after the operation, the temperature from around 80, 85 cannot be brought to 0 or 30 straight away. It has to be gradually brought down by 10 degrees, so that you don't allow the any kind of impact coming on the roll. Okay, keep the rubber calendar running, because stoppages cause your calendar rolls to become egg-shaped, that in turn introduce significant gauge variation. Stoppages also ensures that the pressure in the calendar nib drops down, and thereby it is causing a drop in the calendar thickness gauge. When you stop the rubber calendar, heat loss from the roll is not uniform around the surface. Heat loss along the face of the rolls near adjacent roll is minimal, while heat loss in the areas that are open is higher. So this, any kind of a temperature difference can lead to a variation in the gauge. It is recommended to adopt the following steps to minimize thermal runout. Like keep the calendar running during warm up. If not done, several thermal runout can be introduced. You need to remember that the calendar nib gap between adjacent rolls will be reduced as the rolls enlarge with the temperature increases. So a good practice is to open your rubber calendar at least 2.54, that is mm, before starting to increase the roll temperature above the ambient. So these are all certain thumb rule guidance. Individual companies may have their own setup operations, but what is important to understand here is, don't increase the temperature straight away, ramping up from low level to high level in one shot. Similarly, don't reduce from high level to low level in one shot. It has to be gone gradually. This ensures the temperature transition happening in a very smooth way, And calendar should be always kept running for the simple reason the continuous running of the calendar ensures the temperature uniformly out. Minimize the calendar stops. When you stop the calendar for a long time, remove the rubber from the bank. This is a good operating practice for rubber compound as well, because there is a heat around the calendar and the nib, and when the calendar is stopped and the rubber is in the nib, and if you allow the rubber to stay there, then the rubber may get scorched at the nib, because we are keeping an opening of around less than 1 millimeter or 1.5 millimeter. So the fabric film will be so thin, and it is likely to get scorched, heated up and burnt at the nib. And that nib rubber, when you restart the calendar, and if it is there in the nib, this one small burnt or scorched rubber is good enough to completely spoil the entire volume of compound that is available, and it will lead to a lumpy calendering. So it is very, very essential whenever we operate the calendar. uh, First of all, ensure that minimal number of stoppages or zero stoppages, or even slowdowns have to be very, very minimal. But comparing a stoppage and a slowdown is better, because at least the continuous operation is going on. Only thing is, whenever the calendar is slowed down, ensure to operate the nib profiling in such a way that the overall uniformity of the gauges are maintained across the width. This is very, very important. Otherwise, as the speed reduces, then the gauge variation happens. And again, when the speed increases suddenly to the original level, then the gauge variation happens. So in both the cases, in order to avoid the gauge variation, if at all there is a situation where you have to slow down the calendar, ensure to open up the nib settings accordingly to ensure the smooth gauge, and as well as the squeezing or the loose coating about the rubber on the either sides. When the leader is going through the calendar, dropping of tension and allowing uncoated fabric or loader to go slack permit running the calendar during delays, personal breaks. Okay, whenever you are having a defined pre-planned long stoppages, it is better to pass the leader liner and remove the fabric from the line, because when the fabric is continuously exposed, say for more than 30 minutes to the ambient, there is a good chance that moisture will pick up, and then it can lead to variation in the properties. And for more than 30 minutes, if the fabric is remaining on the line, then the portion of the fabric which is touching the hot can, which is around 100 will continuously be getting heated at one place for more than 100 degrees, which can again lead to a shrinkage of the material and cause a problem in the fabric properties. So it is better that we pass the liner whenever we know that a planned shutdown is likely to be there for beyond 30 minutes of time. So increase the temperature by 5 degrees when you stop the rolls. This is, you need to realize the TCU temperature of your rubber calendar controls the temperature of water exiting the rolls and not the roll surface temperature. This is an important distinction. We maintain the TCU temperature to a desired level by the influence of the water coming into that. So it is the temperature of the water which is inside the calendar roll which is creating that kind of a temperature profile on the surface. So we are actually controlling the water and not the rolls. So it is very important that we don't increase the temperature beyond a particular desired level. So let us look at some two scenarios. When the calendar is not in processing the rubber, that is during warm up and when the calendar is stopped, the roll surface is losing heat to the atmosphere. Here the TCU is actively heating the water loop. In this condition, the roll surface temperature is below the water temperature. When the calendar is running and processing the rubber, heat is being generated where the TCU is cooling the water loop. In this condition, the roll temperature is surface temperature above the water temperature. So these two distinct phenomena, what do you see, creates a differential impact on the running and on the product. To minimize the differences from such processing conditions and variations, the temperature, roll temperature should be increased whenever calendar stops. The temperature increase should be gradual Your specific value should be experimentally determined by comparing the roll surface temperatures in normal operation after the calendar has been stopped for 20 minutes. So when I say this 20 minutes, 30 minutes, it is basically referring to the fact that whenever we are stopping the calendar, ensure that the temperature ramping is given proportionately in a gradual way in order to gain the required set temperature at the calendar roll and ensure a smooth calendaring. Then you should not limit I mean you should limit the temperature increase not more than 3 degrees per minute, because faster rates can damage or warp the rolls. Faster rates of change do not allow for equalization of mechanical expansion throughout the roll bearings and calendar frames. Most of the calendars are hydraulic operations, so they become easily susceptible to this kind of issues. Differential expansion can stress various components of a calendar. In extreme cases, they can actually crack, like we discussed earlier. Again, it is important to keep the calendar running during warm up and during cooling down. Stopping the calendar and turning off the TCU circulation pumps before the calendar reach ambient is not considered a good practice. So as we start the calendar, start the TCU first, take it in a little above the ambient temperature, maybe by 10 degrees. Once the temperature attains, increase it by further 10 degrees. Once the temperature at further 10 degrees. So the startup operation takes around certain time. Similarly, wind up operation also, when the calendaring is finished, don't directly shut the TCU off. Gradually decrease the temperature and create a gradual cooling to the rolls. Minimize speed changes, because changes in your calendar speed result in gum wall thickness, because there is a pressure in the nip which actually varies whenever there is a speed change happening. When the calendar is running, these are forces generated that try to separate the rolls, and these separating forces are proportional to the calendar speed, although the relationship is not linear. So as the practically what we have seen is, if the calendar is running at 50 meters per minute, suddenly you reduce it to 30 meters, then the gauge drops. Then when the gauge drops, if you don't adjust the nip immediately, if you know that the reduced speed is going to run for 2-3 minutes, then you have to immediately adjust the nip to bring up the requested gauge. And similarly, when after that 2-3 minutes passage of time, then you increase it from 30 to 50, immediately the gauge will jump and go up. So in order to avoid that, as you increase the speed, immediately you have to work on the nip profiling to control the nip in such a way that you get a uniform gauge at all times. The hardness of your rubber stock and bank temperature determines the magnitude of separating forces. The thickness of the gum wall being calendared also affects the separating force. Thinner gum walls generate higher separating forces. Separating forces of somewhere between 1.5 to 3 lakh pounds, at each actuator literally stretches the calendar frame. When the forces vary, the amount of stretch varies. This is further results into roll gap varying. That, in fact, this is one of the main reason when the tendency of the loaded rubber into the nib can create this kind of exert this kind of a force and stretch the rolls. You having a profiling in the roll helps to mitigate this stretch and then create a uniform flat thickness on the fabric. Mill management: maintain consistency, preferably use variable speed motor, so that as the calendar speed reduces, the mill speed also reduces, thereby the feed is maintained in a constant uniform rate. If we have variable frequency VFD cannot be managed in the calendar due to cost constraints and other thing, then ensure that the strip width and the strip gauge is maintained, and with the change of speed happening in the calendar roll, that you have to moderate the feed going into from the mill to the calendar. So mill management becomes very, very critical in this case. So there are certain mechanically induced variations also we see. So mechanically induced calendar variation relate directly to your rubber calendar's mechanical condition. It's basically a maintenance issue. And here also we have 5 direct thing: grind profile of calendar. So the roll crowning, as the calendar is being used more and more and more, the wear of crown happens, and this wear of crown is compensated by roll bending wherever the roll bending facility is there. If there is no roll bending, but the only wear of crown is happening continuously, then over a period of time, at a certain acceptable level, when it is crosses that, then you have to remove, stop and get a in situ roll grinding done, or remove the roll and change the roll if the grinding possibility is not possible. Eccentricity of the calendar roll run out at ambient temperature has to be checked frequently on a defined frequency. Condition of calendar roll bearings has to be monitored very frequently. These all should come as a part of the preventive maintenance checks, so that proactive checks are done to ensure minimal losses on the running operation. Condition of calendar roll water passage, and because of the water quality, the pH level, or the kind of minerals that are present in the water, there can be a scaling happening inside the calendar roll. So we need to do some kind of a descaling operations by passing some acid. So we call it as a acid cleaning. So the acid cleaning can be planned once in a 6 months, once in 3 months, depending upon the water quality and the condition, and ensure that the rolls are cleaned inside and flushed out, so that the temperature impact is not caused onto the roll, and thereby a smooth calendering happens at all times. So when we said about roll crowning, I said as the calendar runs and wears out, there is a wearing out of the camber or a crown which happens. So this, in case of a kind of calendar equipped with roll bending, you can actually compensate the wear of the crown proportionately by adding the roll bending to the process. And if it is not there, then you have to do the grinding at some point in time. Then eccentricity of the roll runout. Your calendar rolls must be round and free of runout at ambient temperature. Any runout of the individual calendar rolls will be amplified at the high spots and low spots periodically match between the roll pads. So you can easily check this with the dial indicators when the calendar is running with the, so there is you allow the roll to run in a slow speed and then keep the dial and check. So that will tell you whether there is any abnormality seen in the roll profiling because of this runout. So the bearings have to be checked. There are now, in case of a hydraulic system, the oil level controls for lubricating the bearings are there. In case of a sophisticated calendar, self-lubricating bearings are also there. Despite all these controls, if the roll bearings are going to be bad, then it can impact the calendar performance. So we need to have our own internal controls of checking these up in a periodic way using a preventive maintenance process, and ensuring that this is maintained and controlled. So water passage, like I said, the water becomes very, very critical for cooling as well as for circulation in case of calendar rolls. So one of the chances is scaling, and so we have to ensure that we have to descale the process and the rolls in periodic way, so that we don't get into a situation of a supply of water not being adequate. Most modern calendars have drilled rolls. So the difference between a cored roll and a drilled roll. So drilled rolls will have the water passage going peripherally around the surface of the roll, whereas cored roll will have the water going at the center of the bore. There is a roll and there is a center, a bore is there in the center, and the water passes through that and then gets circulated. Whereas when it is a drilled roll, it goes along the peripheral of the roll surface. So the advantage of a drilled roll is heating is also faster, cooling is also faster. And a disadvantage of a cored roll is it takes more time to spread the heat. At the same time, it takes more time to cool off also at the end of the day. So a drilled roll is much preferable and to operation for a calendar. A drilled roll has water passage across the roll face beneath the surface. These water passages effectively forms a radiator like heat exchanger around the periphery of your calendar rolls. In an event when these passages become plugged, then non-uniform heat transfer will occur, and this results in a thermal out of round condition. And this is the reason why we say that periodic, well-defined periodic treatment of descaling or acid cleaning has to be done to the rolls to prevent the damage and extend the life. So calendar rolls engine actuator, Of the different variants, manual or motor driven hydraulic nip gap adjustment, electric screw actuators are most common type of calendar roll and positioning system. The screw and the nut operate under very high loads, and thus you will observe that they experience significant wear even with proper lubrication. As this actuator backlash develops. So any kind of sensing equipment or sensing devices, it can be actuators, it can be in the roll gauging process also. There is a kind of actuator which is provided, which is working on a magnetic influx of a field, which is getting converted into electrical impulses for control on the panel. So all these things will have to be periodically tested, because any kind of a wear and tear or any kind of a fluctuation happening to any of these actuators and controls can directly result into the gauge variations and can result into the machine failure also. When the backlash increases, the response to small changes or corrections deteriorate. Further, with increased backlash, the number of corrections required would increase, which in turn causes additional wear. Rubber calendars that have fixed speed electric motors with mechanical brakes require periodic maintenance, particularly the brakes, because the sticky brakes will adversely affect your gauge control results. We also have further facilitations where the gauge control systems are given, automatic gauge control systems, even automatic weight control systems. So more and more sophistication being added to the machinery. All the controls which are there to determine and ensure the smoothness of this will have to be periodically followed and maintained as a preventive maintenance process. So there are certain tests performed for calendar fabric. So before we go to this, there is one significant thing which is called as a calendar guides. These guides are provided to regulate the compound within a specified width across the face of the calendar, so that the compound doesn't slip out and go and get crushed under the guide in between the two rolls. This mostly when the guides wear out, the compound has a tendency to pass through the worn out portion of the guide and it gets crushed, and with the temperature in the roll and the film being very thin, and this crushing happens, this will turn into lumpiness, and this lumpy, once one piece of lump gets into the nip, then it causes a full calendering operation to go bad. So guide is very, very important. Guide should be of the hardness of the guide should be lesser than the roll, because the wearing member always should be the guide and not the roll. It should not be the reverse. There are certain tests performed, which is H addition. This the die position is like English letter H, where the cord is placed in between the two rubber, and then when it is put on a jaw of a tensile tester with one fixed end and one moving end, the force that is required to separate and pull out the cord from the matrix of the rubber is judged as a H addition force. Breaking strength, the cord is taken again, fixed to one end, fixed jaw, and the other end pulled, and the force that is required to break the cord is called as a breaking strength. Gauge, the thickness of the gauge is measured using a vernier. Here you have to ensure that the thickness is measured in between the two weft and not over the weft. Peel addition, sandwich addition, this is again a confirmatory test to qualify the extent of good calendering and the addition of the rubber between the rubber, how good and well settled the rubber into the matrix of the calendar fabric. GSM test, this is again a confirmatory test to see whether the calendar gauge is okay or not okay, because there is a specified dimensional 1 square meter, one sample is die is cut, and then this is weighed to give an indication whether your weight is okay or not okay with respect to gauge what is being done on the fabric. EPA distribution check on full width fabric. EPA is very, very important, because ends per inches, they determine the proximity of the cords within a particular given width, and more the number of cords will result into less insulation around the cord and lead to the scrap and tire failure. And less insulation will mean the strength is less. I mean, less number of cords will mean that the strength is less, and it will not yield the proper loadability, and the strength bearing capacity. General precautions: calibration of all instruments used as a part of control in respective control plan. This is very, very important. All equipments which are there in the calendering has to be under calibration. Usage of all components like a compound fabric over on FIFO and aging. So a Kanban method is a preferred method here. No in-process component shall be kept on the floor. None of the material, be it compound, be it liner, be it fabric, nothing should touch the ground, and it should always be on its regular specified MHE, metal handling equipment. Or non-conforming material, if any, shall be kept at a designated area. You should clearly demarcate the OK material and a non-OK material. SPC charts where applicable should be updated at defined frequency. This is to get an online statistical process control of the process that we are doing. Display of SOP, work instruction process standard, control plan, FMEA, internal customer complaints, external customer complaints, then daily work management trend graphs should be available in the workplace. This is to facilitate feedback loop to operating personnel about our own process as well as our process impacting the customer internally and externally. Then field startup setup checklist, fleet checklist. There's cleaning, lubrication, and then tightening, inspection checklist should be available in the department. This is part of basic operation control. Only lab approved material where applicable should be used in the production. A compound cannot be used if there is no lab approval into this. These are certain hygiene parameters which are to be very critically followed. So there are some defects and troubleshooting. Loose coating or rubber peeling. This is the coating of the rubber is very loose onto the fabric. This happens when the nip pressure is very, very low. So that means whenever we are having the speed variations happening in the calendar, this can be very easily happening and impacting this. So bare cords while building and green tire rejections are the effect, and ply separations. So because the coating of the rubber is very loose, there won't be a proper holding of rubber bonding between rubber to rubber, and it can disintegrate from the fabric and come and cause the separations. Corrective action: rubber film thickness and nip clearance between middle and top roll should be properly adjusted. Then control ball temperature, that is the calendar temperatures less than 115 degree. Then stock or fabric style substitution. Basically, no substitution of fabric or stock should be done because everything is intended for a definite purpose, for a definite application. Any kind of a change or variation happening can directly impact the performance of the tire on the field, and it can in turn impact the market as well as our brand image. So it should not be done. So it can lead to lower casing strength if the EPA is low or fabric is used wrong, or denier is wrong. If the higher EPA fabric is used, it may cause low adhesion because the insulation around the cord may not be sufficient. Different denier than specified can cause casing failures. Corrective action: to check the stock on fabric code before calendaring and ensure that tagging is properly there and then identification is available. Then cured lumps and bare fabric. A bare fabric is one where there is no coating on the fabric, so you see the fabric in its original condition, and that is to be removed in the process and not to be used, because if there is no rubber, then there is no chances of adhesion for rubber to rubber holding together in the process. So this will again lead to ply separation and contamination. Cured lumps: basically when the rubber is getting heated and then forming small lumps at the calendar nip. So this, when it can happen because of 2-3 reasons. One is when the compound is loaded more into the nip, then the top surface of the compound, which is excess, which becomes colder, and this cold, when it gets into the nip, which is already the rolls are at a high temperature, this can turn into a small lump. Second, if the bank is not maintained and if it is running out, so some of the rubber going under the guides, and if the guide is not proper and it gets churned between the roll and the guide, this can again come back into the rubber bank, and this can cause a immediately it can cause a spread of lump and leading to cured lumps and lumpy calendaring. So action is avoid having stock. Having lumps should be backed out. Top and bottom compound bank should be controlled and uniform, and guide should be maintained properly. Width variations: this is a direct impact of the spreaders that we have all across: low tension spreader, high tension spreader, and the effect of those things. And when the spreaders are not in proper working condition, center guide systems are not properly working, then they have to be checked and corrected to regulate the fabric flowing at the center of the machine, as well as the low tension, high tension spreader guides are working to ensure the distribution of the cords. Wavy cords, effect is improper coating of rubber film, loose casing. Corrective action is festoon air pressure and correct top roll position. So basically, wavy cord also can come because of the tensioning process. So as I said, everywhere the calendar is a very critical operation as far as the tension is concerned. It should not lead to stretch, at the same time it should not lead to slackness. It should be taut. So that is the kind of tension that we should maintain. Cold calendering, the effect is high gauges, poor adhesion, low tack, surface appearance also very cleanly seen. And the corrective action is the rubber has to be warmed up properly so that proper temperature maintained rubber feed should come into the calendar nip. So feed hot stock to the calendar, heat a calendar bowl by passing steam if necessary. This is not required when you are having a TCU, because TCU controls the temperature of the calendar bowl. So in case of no TCU control, then you have to pass steam to ensure that this cold calendering disappears. Then when there is a cold stock, better to back it out and then get it rewarmed and then put it, then control the bank. Gauge variations, basically when you talk about a gauge variation, this is a cross section showing the fiber nylon, and on both and top and bottom sides you have the rubber coating. So the coating of the rubber, what you see here and what you see here should be same, in order to ensure that we keep the feeding to the stock of the top nip and the bottom nip in a controlled way. So what are the effects? If the gauge variations are poor insulation affecting the ply, then tire weight variations, and this can also lead to immediate failures in the market because of the cord and cord chafing and rubbing against each other. Corrective action is the calendar stack temperature or bowl temperature should be good, and feeding stock temperature should be warmed up and then adequately maintained. Then water circulation has to be in place. More important, speed variation should not be there in the calendar, and stoppages should not be there. Crushed fabric, this is opposite of the rubber peeling, and whatever actions we are doing for rubber peeling, if it goes bit in excess, it will form crushed fabric. Like when I am running the calendar, if I see a crush, that means the fabric is getting pinched at the nip, then I have to lift the top roll, that is roll number 2, to ensure that the pinching is not taking place on the fabric. But when the lifting of the roll number 2 takes place little higher than what is required, then it will lead to rubber peeling. So an action taken on rubber peeling beyond a point will lead to crush, and when action taken on crushed fabric beyond a point will lead to, they are complementary to each other. So it is leading to low casing strength, ply separation. So monitor the stock band, adjust the top roll properly, keep correct festoon air pressure to have the tension in the fabric. And speed, any speed variation, when it is running at a certain speed and suddenly you drop the speed, it will lead to crush. When you are running at a certain speed and then suddenly you increase the speed without adjusting the nip roll, then it will lead to rubber peeling. So before we end the session, I'll quickly run through the summary of the learnings. A 4-roll calendar is an equipment used in the calendaring operations in the tire industry for coating the fabric, whether it is nylon, rubber, rayon, or polyester, or even steel, with rubber on either side, with a uniform gauge and a weight. And a 4-roll consists of, the configuration is of S type or Z type or inverted L type. That is depending upon the shape of the rolls that is present in the equipment. And 4-roll has 4 rolls which can be independently controlled. Roll number 1 and 2 have the cross-axis facility and crowning facility, and roll number 2 and 3 are plain rolls, and there is no profiling into this roll, and they have the roll bending facility. So the purpose of roll bending is when the roll crowning is wearing out over a period of usage, roll bending compensates, adding the roll bending compensates the wear on the crown, and it can prolong and sustain the operation for some more time. And whenever beyond a period this gauge variation is seen because of the profiling on the camber has gone down, then it is time to take the roll for grinding and regrind the roll. There is a splice relief control available. The splice relief ensures that sensing of the splice joint passing the nip is seen and doesn't cause any damage. It is a 3T control: time, temperature, and pressure. So you need to have the splicing time under control, the temperature under control, and the pressure also under control, so that the splice joint doesn't snap up in the run. 4-roll essentially has an accumulator at the start, which is called let-off accumulator, and an accumulator at the end, which is called wind-up accumulator, which is to facilitate a continuous process of changeover at the let-off and wind-up. There is a pre-tension, post-tension to ensure that the fabric is kept in a taut condition without a stretch, at the same time without a slackness. There is a low tension spreader, high tension spreader, which is actually maintaining the width of the roll at all times on a desired level. When the width is maintained, it ensures that the EPI is also maintained properly. Speed controls are very, very important. So maintaining a proper speed ensures the fabric quality good with respect to gauges as well as the scrap levels. TCU is one of the very main important aspect of a for calendar. Maintaining the TCU is very, very critical. And when you maintain the TCU, it also has to be ensured that the roll cleaning in the form of acid cleaning is done on a periodical basis to ensure that the gauges are maintained properly. There is a stock warming process, feeding process. So there is a cracker mill, set of 2 cracker mill, 2 warm-up mills, and 1 feed mill, and which complement the feeding of stock from the mills to the calendar in a very designed uniform way. In some cases, you can have a pork chop extruder, where the extruder chops down the rubber and gets into pieces and sends it to the feed mill, and from feed mill it is going to the calendar. And there is a hot can, there is a cold drums, cooling drums. Hot can is to remove the moisture, cooling drum is to ensure the fabric is brought to the room temperature. And overall, FIFO is very, very important. First in, first out. Identification and traceability is very, very important. In order to maintain both, we can probably use Kanban system, which is more safe as well as very secured process to ensure the process happening in a good time. Well, we come to the end of this, and I hope you had a good understanding about the setup, operation, and control on for calendaring process. Thank you.
Hi, Mr. Kannan. Excellent presentation on the 4-roll calendaring process. We talked about setup. We talked about various operation issues and troubleshooting issues. I really it a bit a longer presentation, but it's very useful for all the tire industry professionals. And so thank you very much for putting a nice presentation today.
Thank you, Param.
So
this is one very critical equipment in the entire operation setup of tire industry, and this has a lot of linkages to processes internal as well as performance external. So this particular calendaring process outweighs everything, and it's very super critical to the tire industry that way.
Actually, that's what I'm going to ask. Pose this question: why it is so critical? You see, in tire industry, you have many segments, right? Somebody compound development, designers. So when I look at it, after listening to the presentation, wow, this is something very critical for the tire industry. So why it is so critical?
Very good question. Fabric in a tire is called as a reinforcement. Whether it is nylon, rayon, polyester, steel, whatever be the thing, it is called as reinforcement. So a reinforcement inside a tire is as good as a bone in our body. So if you imagine a body without a strong bone and a very fragile bone, then the body won't sustain for long. Similarly, if the fabric is not good, ideally, the so-called optimally selected one, and if it is not properly calendared and then adhering to the specifications of the requirements of calendaring, then it is like a weak bone in a body. So the bones are there, so the fabric will be there. It is looking, everything looking black in the tire, but then when it goes to the performance in the field, then it would show up. So what makes a good company from a bad company is this: when I make 100 tire, all my 100 tire perform X kilometers plus minus Y kilometers. Whereas some companies make 100 tires, out of which some tires are performing 2x, 3x, but there are some going within no time. So the customer who buys a tire which runs for 2x, 3x is like buying a lottery ticket. But for a person who is losing that, then he will never come to you again. So this is a critical difference between a successful company and an unsuccessful company. So this demarcation happens essentially because of the stability and the capability of the process. And for that, particularly in calendaring, it is very, very pertinent to have a stable calendaring process. And in order to have that, all these, whatever I have guided or whatever I have told in the presentation, they are super critical, because when those things are in right place, then the tire becomes a good serviceable tire, and what a customer can look for in the longer run. That is why it is critical.
So the tire performance depend on your calendar process. Okay.
Correct. Absolutely.
So it implies into the safety or all other matters.
Everything,
right?
everything. Yeah. Because the purpose of tire is to carry load, take speed on the road. And right. The tire, when the tire is running on the road, whether it is a tar road or it's a cement road or whatever, even gravel road, wherever it is, it has a tremendous friction happening. As the speed increases, as the load increases, there is a tremendous friction happening. So every friction happening will induce a generation of heat inside the tire, and rubber being a bad conductor of heat, so it cannot dissipate the heat outside. So we are providing for the design itself where the venting channels are available, yet the inherent heat that is developed inside the tire cannot escape out. And when a calendering is not proper, the coating of the layer rubber on the nylon above and below, if it is not equal, what happens is the insulation becomes very thin because of uneven gauge or because of off coating or imbalance coating. And in such cases, when the heat generates and a continuous operation of load and speed is there with the friction generating, then this insulation, which is very weak or thin or low gauge, this gets subjected to a very high kind of a pressure, and then it starts thinning out. And at some point in time, with the heat and the rubber getting eaten away, then you will have only cord and cord touching each other. So when the cord and cord touches each other, it rubs off, and the chafing of the cord will actually lead to the failure. That is, you start seeing the ply separation and things. So when a ply separation happens in a running truck, the tire can burst also. When tire bursts, then you know what are the consequences. It's the highest safety consequence, what we can think of. So that is why more than compound, well, compound will have a some kind of a element of performance characteristics being judged in. Profiling of extruder, some kind of a performance character, whereas in the calendering operation is bad, it is directly unsafe. So that is
if I put so the people who is operating calendering, they get more money as salary.
I wouldn't directly equate it like that. See, even in any operation, manufacturing operation, the full ambit, if you see, the positions of working can be divided into 4 categories: highly skilled, skilled, semi-skilled, and unskilled. For calendar operator, he has to be minimum of a skilled to highly skilled. If he's a skilled, then he should be backed up with a good experience. If he's highly skilled, then it is perfectly okay. And second, this we call as a skill level of the position. And then there is a skill level of the operator. So there is again a 4 levels of skill levels in operation. The first step is a learner who is absolutely new. Then he goes to execute mode. With the help of somebody, he learns, and then under their supervision he can work. Then he goes to Excel mode, where he can work independently. Then he goes to propagate mode, where he can also work and teach somebody. So in particular calendar, he should be in the Excel mode or P mode. So that we call it as a leap model in HR. So this is a leap model, and position role clarity wise, there are 4 levels of skill. So the skilled operator or a high skilled operator with the Excel or propagate, only that combination can be a operator in a calendar. Otherwise, it can be catastrophic for two reasons. One is internally your scraps will go high and conversion cost will be too high. Second thing is it can directly impact on the safety and operational functional characteristic of a tire.
So the reason I ask why it is, of course, we always look at the based on the importance of the job, the remuneration or perks thing. But when you're talking about a skill, I think you rightly mentioned about the skills. So this operation of this calendar requires a good skill, so that you have, there is no issues about the quality or the defects. At the same time, also safety of the the tire performance, for the public itself. Yeah. In your experience, you've been in the tire industry for many years. Currently, you are also consulting. What kind of typical mistakes these operators do? And what is the range of defects you may see? Kind of again because of the calendaring problems.
Wonderful, good question. Very good question pertaining to the any tire industry. This is a very common question. An operator is like a pilot on a plane. So it is not that he's only operating. His eyes, ears should be open to the entire surroundings of the mission. Like I was more privileged to be associated with one associate of my company. While operating, you will be talking to me. I was just a new guy and I was interacting with him. While interacting with me, you will say, Kannan sir, wait a minute, jara udhar kuch to bearing ka problem hai, dekh ke aata hu. So I used to tell him, you're talking to me. How do you know that there is a bearing problem? So he said, I'm talking to you, but my eyes and ears are everywhere. So they will be able to absorb each and every small variations, small deviations, even in the sound. And many times I have seen when this kind of a issue comes up with, we call the engineering person, mechanical, electrical, electronics, we call them and tell them he suspects there is a problem. So please look into that. So that engineer will tell absolutely there is no issue. He I mean, he thinks he is too much of himself. But when you actually go and open, the bearing would have gone. So that is the extent of commitment and that is the extent of focus that an operator should have in calendar. Number one. Second, I already explained in the presentation. Basically, what happens, the output of a calendared fabric is judged by some 3-4 major parameters. One is gauge of thickness of the fabric. One is width of the fabric. And one is a weight of the fabric, or what we call as a grams per square meter, GSM. And then there is the EPI, ends per inches. In 1 inch, how many cords should be there? So these are the 3-4 obvious things which a production man or operation man has to look at. What happens if the width is less or more? When the width is less, then the chances of cord getting crowded is there, either at edges or at the body level, wherever it is. So in the tire design process, the EPI is calculated based on the backward calculation of what is the tire strength required on the field. So what fabric I should use, what denier I should use, and what EPI I should use, everything is back calculated based on the strength requirement. Now in that, if I'm saying like for example 25 EPI I'm using for a particular truck application of inner body ply. Now that has around 0.75 to 77 millimeter as a diameter. Now multiply that by 25, this itself comes to around 16-17. Now in an inch of 25, if 25 cords will have to be placed, and you already have the width of this covering up to 17 millimeter, you hardly have 8 millimeters for the rubber distribution throughout. So in that, if another 2-3 cords get together, what happens? The insulation around the cord weakens. And this is one of the critical initiator for a failure in the field. Like I said, because continuously there is a friction and happening on the road because of the load and the speed. So when the heat generates, this heat will eat away. So that is the reason why width is important. Now, if you look at only the edge crowding happening, not in the body. Now, in next stage of calendering is bias cutting, where we cut the fabric at an angle and splice it on the edges. So when I am going to make a splice on the edges, because it has to form a continuous loop at an angle, in that splice, I will have a 10 millimeter maximum splice, one on another. So if 10 millimeter splice has too many cords crowded, then obviously the density is so high, the insulation is poor in the single fabric. Added to that, when I make two one-on-one, so obviously there is not going to be any rubber. And this, when it is going on a turn-up area, so the turn-up area, this gets maximum brunt of the load. So the failure starts from there very fast. So it is very important not to have edge crowding, not to have overall crowding also, which means the fabric width is less. Now coming to gauge, my gauge has to be proper because insulation above the cord and below the cord has to be equal. If that is not there, then one side where it is less, the other fabric, when I do multiple plies, if the other ply when I'm putting, if it also has a lower component of rubber, or even that is okay, when this is less, the amount of rubber the bottom is less, this can induce failure over a period of time. So operators generally what they do, they wait for the stock to come, and the stock doesn't come on time, they reduce the speed. So for them, the immediate effect is there should not be any bare fabric going. That's why they reduce the speed when there is no feed coming in. But when they reduce the speed, if they don't adjust the nip, then what happens? The gauge drops. So the gauge drops so considerably down, and at that portion, if you cut a sample and check the adhesion also, adhesion will be the poorest because the pressure in the nip reduces, so the squeezing impact is not there. Gauge is down, squeezing impact not there, and the adhesion is also not very cohesive. So this is a good reason for separation to take place in there. So what we normally tell the operators, first of all, speed has to be constantly kept at one level. It should not be changed. Whatever factors necessitating this change in the speed, that factors will have to be worked, not the effect. Effect has to be that it is on the constant speed. So if a mill is a problem, attend to the mill. If you feel 60-inch mill is not able to feed that much stock on time, make it to 84-inch mill. But if you feel my strip width is less, make it into a bigger strip width. Or if my gauge is less, make it into a higher gauge. But ensure the temperature is okay so that the requisite viscosity is available at the calendering operation nip. So these are very, very critical. Similarly, once you reduce the speed and suddenly when the stock comes, then automatically in order to cover up the production, you will increase the speed to the optimum level, design specification level. So when the travel happens from a low speed to high speed, that immediately it perks up the gauge to such a level. Like if I have to give you figuratively, if I am running a 1 mm gauge fabric, when I reduce the speed with no stock or less stock on the mill nip, so what will happen? The gauge will drop to something like 85, 86 or even 90. Then when the stock comes and immediately restore the speed back to normal, it will go to 1.1. So now what happens? My range of the gauge varies from 0.90 to 1.10, while my specification is 1, and my tolerance is available as a 0.0 plus minus 0.05. So one is uneven distribution of the gauge. Uneven distribution eventually leads to failure. And second, any amount of excess rubber going, it is going to add more weight to the tire. And rubber being a bad conductor, it is not advisable to put more rubber into the tire more than what is required. And third, and last but not the least, any additional rubber you put, you're not going to get the payment from the customer because customer is going to pay only for the original tire cost. So it's a loss to the company. It's called a COPQ, cost of poor quality. So this is how we tell the people speed control is very, very important. So they have to ensure, and width control is very, very important. And periodically you cut a sample and check if you don't have the automated control, balance how it is there between top and bottom, whether it is equally balanced. These are the three critical factors.
So so operator role is very important. Now I'm asking you, what is based on, if you talk about best, what is called benchmark, benchmark, what is the percentage of defects in calendering process? If you set a benchmark.
See, I'll tell you, calendering defects, when you say it, we call it as a scrap because eventually it cannot be used. It cannot be used anywhere. So it goes as a scrap. So the scrap, ideally good companies, they monitor scrap on two methods. One is I produce so many tons of tires every day. For that, so many tons, as my fabric requirement, I produce some X tons of tons, I make tire, Y tons of fabric I generate here in the calendering. So the total scrap that is coming out from the system, whether it is in 4-roll calendar or subsequent operations, wherever it is, when I accumulate the whole thing, I have metrics to measure it against the overall tonnage as well as against the produced tonnage. That is calendar fabric produced. So companies monitor both. Okay, there are some good companies monitor both. Some companies, because of operational assessment process and other thing, they make it on the overall scrap. So a good company with a scrap control and everything, you should maintain it at something like 0.1% of the tonnage.
So
Very
that's
tough,
kind of
very tough. But if you maintain it at 0.1 to 1.13 kind of a thing, then we are doing a good justice to the company. Generally, with the new calendar, new process, new company setup, when such things are there, the scrap goes up to even at 1%. So lower the tonnage, higher the percentage. Higher the tonnage, lower the percentage. So it is taking the shelter under the tonnage, basically denominator. That's why I said irrespective of the tonnage, the fabric that you produce, when you match it against that, then that gives you. And there is nothing like a ideally best. You can keep the benchmark, but everything depends upon your calendar condition, your operation condition, your setup, and independent company's situation. Like I can't look at 0.1 as a benchmark and keep crying and when my equipment is bad. So it all mix and matches with so many inputs.
Yeah. So you I think you addressed the point, bad equipment. So
Yes.
one would be one of the reasons also cause the troubles. Let's talk about, if somebody is going to buy the new calendar or replace the existing calendar because they're getting in so much trouble. What do you suggest about how they should select right calendar for their company? What are guidelines? Give them some guidelines about it.
This is again a very important and very good question, because everything has to balance with the kitty that you have, about the capex and your ability to pump in money. Okay, when a new company is set up with a lot of capex in hand, you can always think of going for a modern calendar, which is embedded with all these facilitations of roll bending, roll crossing, crowning, and splice relief and everything with a high speed. But that is not the situation all time for all companies. Unfortunately, in India, when you see, whenever we go for buying machinery, that is the time all cost cutting initiatives come. So there are two critical aspects. My initial cost is less, means my capex is less, but my opex is more. So both are KRAs of two different people.
Sure.
Capex is a KRA of project team, opex is a KRA of operation team. So capex is the main focus for project man, and he will try to settle for something. Maybe I'm not telling a country is bad, good, and all. Maybe you will get a very poor quality machine, which may have everything, whatever I said, but the reliability is so poor. So it may run for 2 years, 3 years, and then it will conk up. So if my good calendar is costing around say 40 crore, I'm probably getting a 6 crore machine with the same features from a cheaper source. So I think that my project cost can be saved. I'm giving him whatever he wants. So some amount of quality is already there. It's all depend on how these people maintain it. So I put the buck on operation and I give it. But then my project is they say no, battle won and war lost kind of thing. So it is something like that. So I may save the money here in the capex form, but my running operating cost is going to be so expensive that I'll be crying every day. It is a cry for one day, it is a cry for every day. So it is always a balance between these two. If at all you are not in a position to go for a completely super facilitated calendar, at least go for a standard good calendar available with some minimum requirements, like roll crowning is anyway required. Without that we cannot work. Suppose if roll bending is not there, roll bending is there, roll crossing is not there, friction is not available, and splice relief is not available, fine. I can't get a 90 meters, 60 meters, but I can go for 40 meters, fine. That's a kind of compromise you have to do. But settle for a standard known company where your long time expenses are going to be completely under control compared to the other cheaper source. That will be my advice. But again, it depends. As I said, every company doesn't have the same weight of purse, so it has to balance between this and that.
And I think I mean, many times I come across operators, we always say that the operator is not skilled for the problem. Sometimes we don't look at the right selection of equipment, provide them, and so that they can operate smoothly. It's a bad judgment, in terms of selecting, having the right equipment. Of course, you understand it's all about the what is your weight in the wallet, okay? But I think you rightly mentioned about the OPEX is every year, every month expense, but CAPEX is one-time expense. So, and or you talk, if you look at the mechanical parts of the machine, what are the things they should really careful about?
Yeah, again, particularly in a 4-roll calendar, it's not only 4-roll calendar, this is applicable to extruder also, mixing also. There is always a varying member. In case of 4-roll calendar, varying member is a roll diameter. Yeah. In case of extruder, varying member is the screw or barrel. In case of Banbury, varying member is the rotor. So, because there is a continuous action happening, there will be some varying happening. For that varying, you should have an assessment being done on a periodical basis. So, in this case, how much is the roll varying out? So, given certain controls, I have a control of TCU, I have a control of what should be the speed, I have a control of what should be the operational criteria for feed and compound viscosity, everything I have. And assuming I am following all these things completely in total. Now there is only one differentiating factor, which is wear and tear. So the wear and tear, I need to understand how bad the wear and tear is given the operation conditions being fixed. So unless I start mapping that data continuously every quarter, every month, so I normally recommend every month they should do one, the film sample. When you run the calendar, you do the setting. Every setting is done and then given to the operation. Now, given the situation, because of so many, there is something called a temposonic, which is actually actuator, which can malfunction with respect to heat because it's an electronic component. And when that malfunctions, the gauge goes off. Then you have to keep on adjusting the setting. So what is your original setting and what is the actual current setting? When you measure the gap in between the nip, it will be totally different. So one way of every now and then you can't measure the nip because it's a time consuming process. It's a 8-hour process. So what we recommend is once in a month, at least on a standard fabric, fast maximum running fabric, you should take the gum wall thickness end to end on both top film and bottom film and check whether the distribution or the proportion what you have given and what is there is exactly meeting the same or different. If it is different, plot it and see where it is going wrong and accordingly fix it up. At least once in a 6 months, if once in a quarter it is done, very good. If not, at least once in 6 months, you should do the exercise of roll gap measurement. There are certain criteria for that. Given the criteria being established and followed, I will measure the gap between the two rolls on a fixed position. So that when I map it, I know when I'm, suppose if I'm saying roll number 2 and 3 is a plain roll. So I take a 1-inch gap, 1-inch gap equidistant from the center and make it equal. And I measure the gap throughout the width. If everywhere it is 1 inch, that means my roll is perfect. Suppose if at some place it is 1 inch, somewhere it is more, it is less, then there is a wear out seen in that, or operational disturbance is seen in that. Then you need to check like that between roll number 1 and 2, between roll number 2 and 3, between roll number 3 and 4. So the nip gap profiling, what you do between 1 and 4, 1 and 2 and 3 and 4 will tell you how much is the camber in place or how much is the camber worn out, camber or crowning which is worn out or it is in place. So this is a mechanical part. And second thing, most of the calendars are hydraulic based. So when it is hydraulic based, the oil what we are using, viscosity of the oil and frequent checking of the oil level controls, although they are all visibly available in a scale, but it has to be checked and monitored. And most important, for any good company, you should have a preventive maintenance schedule. A preventive maintenance schedule should be in place. So there is something called as a routine breakdown maintenance that happens over a period of time in a day-to-day operations. So those can be categorized into two sections. One as MTTR, one is MTBF, mean time to repair and mean time between failure. Both are important. If the failure happens once in a month, but every failure takes 3 days, then that is a critical thing for me. But failure happens only for 5 minutes or 3 minutes. Like, some tripping is taking place, I go and reset, 2 minutes gone. But it happens 100 times a day. So that is also a problem to me. So I cannot neither ignore this nor ignore that. So I have to have a focus on MTTR and MTPF both. But after analysis, take the critical input from both and transfer it to the preventive maintenance checklist, so that once in a 15 days, when the preventive maintenance person comes from engineering and then does all the checklists, so this should be checked, so that this is potentially going to proactively avoid this, checking and avoiding at a later date.
We'll talk about this mechanical parts, extension of the rollers. Do you have any suggestion when you must remove it or replace it and put a new rolls, or is there any guidelines on it? Or
like I said, once you create a schedule for checking once in 3 months or once in 6 months, and start collecting the data and analyzing the data speaks for itself. In a cycle of 3 months, it wears out. If I take a 3-year data, because in new calendar you will not have any problem. So when you start compiling the data of breakdown, MTTR, MTBF, this kind of data checkpoints and the NIP gap profiling, so it gives you some indication about how the wear pattern is coming. So that wear pattern, if you see it is once in 3 months, then you have to ideally fix it at a minimum 2 months or 2.5 months. I should, before it goes to the third month, I should get it checked and take a call whether I should replace it, change. And there is a systematic TPM approach. Not everything needs to be replaced, not everything needs to be repaired. It all depends upon the extent, and you should have a standard against each and everything. So whether it goes for replacement or repairment or reworking, whatever it is.
So when you buy the new machine,
one important thing in this is calibration is very important, because these are all modern calendars are all coming with most of electronic things. So calibration plays a very, very important role. If the calibration is not done on time and perfectly, then it can lead to any kind of a catastrophe. Yeah, you asked something.
Yeah, when you're buying the machine or new calendar, it's important that the supplier, the manufacturer supplying the right rollers, kind of prepared, or what you call treated. There is some guidelines are there. Is it right? Yeah.
Yes. Yes. See, here also the specifications are shared between the vendor and the buyer, and there is a team of buyers who go there and inspect the facility and look at the processes and certify the processes. And also, wherever possible, you can check and reconfirm the effect of properties. You can do that. That's not a problem. And plus, there is already a clause which says that for 6 months, 8 months, 1 year, 2 years, whatever the operational the observation period. So that is also there. Some money is held back also as a in case of a future thing. But more than anything, understanding of the requirement is very, very critical. When you go to supplier will have a standard inputs going everywhere. But your operation, for instance, I'm just giving you, my business is doing only cross-ply tire. I'm buying a 4-roll calendar, and my business is only radial tire. I'm buying a 4-roll calendar. Both are different. Although the fabric is maybe similar, but my compound used here, radial compound, is totally different. The natural, the cross-ply tire compound is different. So the wear and tear that is going to happen on the machine is going to be extremely critical for radial tires. So when I go for, and moreover, cross-ply tires, we put number of plies, 10 plies, 12 plies, 14 plies, 6 plies, depending upon the size. Radial ply starts with 2 plies and goes up to 3, or maybe number of belts will be there, because that's the fundamental technology difference between a radial and a cross ply to give flexibility. Now, because the plies are less, and if your calendar is also not good enough to back you up, then obviously the product will be bad. When I say bad, it will be unstable and incapable kind of thing. So the specification formation while buying a calendar forms a very critical input for buying any calendar. That depends upon the company's operation type, the what are the sizes made, and functionalities where it is going and things like that. Because skill can be acquired. Skill acquiring is not a problem. You can call the principal to come and teach us. Maybe you put some of your best people there and get them skilled, and they themselves later on transfer the knowledge to somebody else around. But understanding the specification, if it is not proper, then you are more likely to run into trouble. So that is very critical. This is according
Is,
to me.
is automation is possible in the calendaring process?
Yes, automation is possible. There are calendars operated in the world. I'm not taking the names, with only 1 or 2 people maximum in the entire setup, because mill operates automatically with a variable frequency drive, lot of changeovers, wind up changeovers. There is auto change process is there, but everything costs money. And you have auto gauging system, you got auto weight measuring system. So when the gauge is going below or above a particular level for ABC reason, then the nip automatically opens, adjusts, closes. So everything is available. Today technology is so superb that if you have money, you can get everything top class. And again, this will reduce the dependency on the number of people deployed, which is a long term.
Yeah, I mean, if it is if you're looking at a long term and less, what you call it, scrap, I call it the defects and overall defects. Okay, this is worthwhile to invest in automation. So.
Correct, but we have to be wary of one more thing, particularly in a country like India. When you compare Germany with India, or any other Japan with India, the strength is manpower. Okay, because you have huge manpower available with us, and the so-called educated manpower is also available even for ordinary operational jobs. Okay, so you can leverage on that to a greater extent by not investing on the machine upfront with so many crores, given the capex constraint. But if there is no constraint, you can always go, because it will be a very healthy, lean, trim factory.
Okay, we talked about operation issues, mistakes. We talked about a machine. Let's look at the raw material. Of course, you wanted to. Yeah, of course, you want to operate well, but the way you handle your fabric, or the way you source the fabric, and what kind of suggestions, what kind of experience you got? Are there any mistakes happening in handling and sourcing of the fabric before it get into the calendar?
Okay, it's again a very good question in the current context. There are two schools of thought. I have to focus on my core business. I am a tire manufacturer. I will manufacture tire. I will not get into the fringe activities. That is one school of thought. Other one is, I have a facility, so let me do everything. For example, I have my dip unit in my place, so I buy a undipped gauge fabric, raw fabric, and dip it internally, and convert it into calendar fabric and sell it to the market. Now, since I am a basically tire man, my focus and importance, investments, as well as upgradations technologically, skill wise, on the dipping process will not be as high as what it is in tire, while it is an input to my process. So this was happening in most of the Indian big companies. Over a period of time, they felt that I think we should not focus on that, because that is an NVA, non-value added activity for us. So let us hive it off. So looking at the other perspective, the sellers of gauge fabric, raw fabric, they also thought if I can add value and give it to them as a ready dip fabric, all that they have to do is take it and then load it in the calendar and then run.
Yeah.
So it reduces the inventory holding, it reduces the operational cost, it reduces so many unwanted scrap happening, variations happening. So it's a two school of thought. If I have a facility which either I take a call to dump it, wind it, and give it to somebody else, and then start buying outsourced fabric, or I want to use it here. So it all depends upon the company's mindset and thing. But I generally given a thought, we should focus on our core thing, give it to, get it outsourced as a dip fabric, so that the responsibility of getting a good fabric is what you should look at. So which mean, what I mean by this, you go to the vendor, do all the assessments, all the trials, all the evaluations, validations, you satisfy yourself completely, and on a regular basis ask him to share with you all the statistical charts. So the statistical charts, they don't lie. So you get a clear feeling of what the fabric behavior is or the property behavior is. So you are assured of your good product. At least you can focus on calendaring and you can focus on the tire making.
Is that happening in India in a big
Yeah,
company?
now I think most of the companies are gone for buying dip fabric. Most, like I said, maybe there are some units still, because they have a unit, they may be, good unit may be there, so they may be wanting to not sell it at a cheap rate or give it off, and then they may use it. But by and large, everyone is now going for only bought out fabric, which is pre-dipped and ready fabric to use. Well, having said this, whether it is internally dipped one or externally dipped one, the care and handling methods of fabric is very critical to every tire company, and that is where maximum goofing takes place. When I say goofing, if it is a small company with a low tonnage, and if they get a roll, small roll, 50 meters, 100 meters, then the scrap is going to be more, because every time you have to join. So if you buy a big roll, I need only 100 meters for my consumption, but I make 400 meters because I don't want to have too many joints. So, but when I do that, here also I don't do the packing after once I cut the roll and keep it, then I don't keep the storage in the proper place. So all these things, because fabric, nylon fabric, if it is not properly covered and kept the way it is recommended, then it will lead to a lot of quality issues. Like absorption of moisture is the first one, and then it will lead to bagginess. When the bagginess comes or tight edges comes, then it is going to cause a hell a lot of a problem in the operation in calendar itself, leading to so many varieties of scrap being generated. So when you look at that golden thumb rule, which I prescribe as a quality man, an operation man, no in-process material, no in-process component, whether it is liner, shall touch the ground. When I use the word shall, ISO language, it means it cannot touch the ground.
Yeah.
If you follow this golden doctrine, your scraps will automatically come down. And whenever you are using a roll, part roll, ensure that packing is done, the silica gel is poured, covered, and then black poly is done so that UV rays don't affect that. So these precautions are taken. I think we are fairly done with a good operational control.
Super. Well, Kannan, it's nice, I think you gave us lots of inputs and advice, not only with the presentation, but the discussion also. You addressed very, very important issues for the 4-roll calendar. Thank you very much, for taking the time and giving all the knowledge that industry needs to know. Okay. Once again, any final remarks to the audience, please?
Thank you, Param. Thank you for the opportunity to, because like I said in my opening slide of the presentation, the learning has to culminate in joy. Joy comes when you share what you learn, not when you keep it to yourself. So this is a joy I get when I share my whatever knowledge little I have with people, so that it can benefit them. So that's for that I thank you for providing me the platform and opportunity. And as a summary remark, if I had to give, I can only say that, put only the adjudged skilled person on for roll calendar. Don't put any Tom, Dick and Harry, because it's a process which needs so much of a critical focus. Put only the skilled person who knows the job, who understands the machine, who understands the process. Point number one. Then that person should be operating the calendar without a speed variation, without a stoppage. For that, he has to ensure the mill supplies the material on time every time, continuously. If these two things are taken, and of course no material on floor, I think we are done for the day, and we are too good to hold our scrap in control.
Right. Kannan, thank you very much. I think before I let you go, I want you to repeat that shlok in slowly. Okay, the learning to joy, both in Hindi as well as in English, as a final kind of conclusion for this session, please.
Oh, sure. Vidyam dadati vinayam, vinayad yati patratam, patratvat dhanamapnoti, dhanat dharmam tatas sukham. विद्या विनय देती है, विनय से पात्रता आती है, पात्रता से धन आता है, धन से धर्म होता है, और धर्म से सुख प्राप्त होता है. This is supposed to be Shubhashita. So when I do it in English, a true knowledge brings humility. From humility comes worthiness. From worthiness one gets wealth. From wealth one does good deeds, and from that comes joy. So end of the day, whatever we are doing is inherently to create a joy in us and spread the joy all over. As simple as that. And that's life.
Kannan sir, thank you very much. It's a perfect conclusion for this session. I really enjoyed it. Thank you very much.
Thank you so much. Thank you everyone. Thank you audience.